Well, good morning. I'm Jim Harries, a geographer at Esri. I work as a product engineer, helping software teams at Esri, throughout Esri, improve their map products. And I have a particular interest in why didn't we get a good map? What are the factors that led to this map not being as good as it could? Are they human factors? Are they software factors? Are they data? All the above. And I'm joined today by Jennifer Bell.
Hey everyone, Jennifer Bell. I'm a product engineer on the Living Atlas team with Jim. I'm also a geographer, and I'm excited to share smart mapping with you guys today. So why use smart mapping in your development work? Well, smart mapping helps you explore your data and find patterns that you might not have known existed before. It helps improve your maps. Not only that, it inspires ideas for custom maps and different styles and renderers. So today we're going to talk about really exciting new enhancements in smart mapping, what is new and what's to come as well. And we're going to talk about how we've re-envisioned mapping through data-driven workflows, intelligent defaults, coordinated styling, automated scale ranges, and new thematic renderers. All right, so the talk is divided into a few different sections. So we'll start with, what the heck is smart mapping? Has anyone used smart mapping here? Okay, perfect. This is the great session for you to learn about smart mapping. So we'll talk about mapping the simple, just to the location, mapping where something is. Then we'll add a new dimension. What is it? What are the categories? Then the quantity, how much? And then mapping relationships, multiple attributes in one map. And then at the end, we'll map data that does not exist. So that's a fun one that I'm excited to talk about. So we've got ongoing work. Smart mapping is used to help solve our common problems, and it's a solution that developers can use.
Yeah, a lot of times we notice that maps are a huge part of the user experience. They're a big part of the real estate of your app. Maybe not on the initial screen, maybe it's only for part of it. And so if the map is taking up a huge chunk of your screen and the map isn't good, what we noticed is a lot of times you end up with this situation. The developer pointing to the map maker's pointing to the developer, the data person's pointing at both of them, and lost in the triangle of data, software development, and map making is the responsibility for ensuring, is this a good information product? Like, what happened here? And we notice that over and over. It's not unique to any technology or any particular organization, but smart mapping in part was organized as a project within Esri because we kept noticing that, boy, it's really hard to get everybody on the same page. And we started to ask ourselves, what if it were easier to understand your data on the map? What if every time you touched the map or the layer on the map, it gave you immediate feedback and told you whether you're getting closer to a signal or you're getting further away from answering this question? Why are you trying to make this map? Right? Has anyone ever made a map in our software or anyone else's software where you're not exactly confident in what you're doing? Anyone ever made a map? It's back up there. How many of you feel immediately confident the very first version of that map you create? Yeah, it's rare, isn't it? You got to warm up to it. It's kind of like when you build a resume, which I haven't done for 21 years. But as I recall, building a resume is a lot like making a map. You have facts. You know you want to get these facts out, but they're not random facts. There's a structure and a style to it and a purpose to it. And those are three different things. Maps are very much the same way, and a lot of the smart mapping approaches, as we show today, were invented to kind of help you gain confidence with every move rather than lose confidence with every move. All right?
Yeah, I like that. You really have to hook your audience with a really visually pleasing map, but then the map also has to be smart. It has to have good breakpoints and good color decision. And so the point of smart mapping is to make it available for everyone.
Yeah, I agree with that. And
not just a geographer.
We're not necessarily here today to say you will be the map maker we hope at the end of this session you kind of realize you could be the map maker, or you could be the person setting expectations about what this map ought to do, or you might be writing code and realizing that the map that's being made, it's inadequate. And you're starting to figure out why that is. And we'll kind of talk to that. Actually, this slide kind of jumps into that.
Yeah, so we have reality, the real world, what's going on. And then we create data that tries to represent reality as close as possible. And then from the data, we analyze it, we interpret it, we try to find the patterns. And from there, we share it to the world through maps and charts and infographics. And then it's up to us, the people, to make the decisions, data-driven decisions.
We notice a lot of times with technology, people get stuck on one part of this wheel, whether you're a developer, a project manager trying to organize the work, the cartographer who was asked to jump in and help out, or the data person who's trying to get everyone above to just understand how important this data is, right? And at each step along the way, there's an opportunity for us to lose some signal, to lose some things, right? People have their perception of reality, and the data itself may be a little biased in how it records reality or tracks it or represents it. Of course, when we analyze and interpret, we want to do the best job we can. But now notice that once you're in the software and you're building a map or building a chart or a table, you're now doing analysis on something that isn't reality. It's something that purports to represent reality. And at the end of that, you're going to present this back to a user or someone who actually knows about the reality you're talking about. And they're going to call BS, aren't they? Right? You ever talk to a UPS truck driver? They do not like those little pieces of software that route them. They want to make left turns. And the management at UPS says, we don't want you making left turns. Statistically speaking, it's a problem for drivers, accidents, et cetera, et cetera. But there are those tensions, right? Those are just part. I just want this chart. I like this chart because at the end of this, the action we want people to take will connect back to people who live in reality. So if all these maps and data and products don't work well, you're going to hear about it, right? And that's what our inspiration was with smart mapping. I'll give you an example. Let's say that this is a data set of people in this room. You've got Jim and Jennifer represented at the top. It looks like we each have a body temperature of 98.6, 37.1 Celsius for those so inclined. And the measure says normal. Congratulations, you're normal. There's someone named S. Knees in the room who's running a 99.1, technically a fever, and GR Umpy is running a 103. Which of those four people do you think we need to take action on? Right? Why do we all know that? Ask yourself that. Why do we all know that? I'll tell you why, because we have a shared understanding of body temperature, don't we? We've all been there. We've all run a fever or known someone who's run a fever. How many of you ever run a 103? Yeah. Okay, so we have a shared understanding. And so it's a little easier for us to understand what's the user experience of this information and how is a map or a chart. If I could show you a seating chart map with body temperature, how many of you would look at it right away? How many of you would ignore it? Nobody's going to ignore that. Come on, you're going to want to know, is that guy running 103? Because I got to know if I'm getting on an airplane later. The point of this chart is just to make us all aware. This kind of hit me like a ton of bricks one day when I was realizing why, we've built all this smart mapping software. Why don't people just use it? Well, sometimes we don't know what the magic number is. With body temperature, we do, so it's easy for us to all have a quick conversation. If I made a map of this room's body temperature, would you want the person with the 103 to light up on that map in a bright color and size? Or would you want to use Jenks, natural breaks, to see if that person lit up on the map? No, your job is to find the magic numbers and apply them to the map, right? And I'd argue that 98.6 is a magic number here, 101, or what do we say, 99? If your kid comes to you with the 99, you're like, let's go to the movie anyway. But 103, we got to do something.
Yeah, so smart mapping helps you find that magic number that Jim was talking about, and it helps you make really stunning maps very quickly and with confidence. and it makes the map authoring experience easier. And with data-driven workflows, you can make the right choice for whatever project that you're working on. And we bake the expertise into the tools. So these defaults that we have make it a lot easier and more statistically significant in how you're representing your data. So it's the democratization of data visualization. That's a mouthful, but basically it's for everyone.
But like any democracy, participation, your participation is key. And that's the purpose of this presentation. I guess first we're going to map where.
And what.
And what. Who's first, me?
You're first.
Oh, excellent. All right. Let's go to a spreadsheet. That's.
Now they're going to leave.
Okay, cool. First, we're going to show you a map of code violations in this area of Amherst, Massachusetts. And this is kind of the before picture. You know, each of these is a code violation over a period of time. We happen to have a nice pop-up here that tells you, you know, it's a building code violation and its status is closed, failed to register. So sometimes when we map where, you never notice this kind of problem where there's a cluster. There's 5 different code violations right there, and there's even more up here. And depending on the scale at which you operate, it's always important to think about, I always advise people, when you're mapping, think about what is the initial scale that this map will appear at, and work at that scale first. So if you think the scale is going to be this, notice how many dots are on top of each other. And that's just a reality of when you just throw dots on a map, you're going to have this issue. And there's 2 ways in smart mapping to counter that. Smart mapping is found here underneath the change style button. I'll show it one more time. On the layer, if you pause, there you go. You got to pause. And change style appears, a little tooltip. And if you touch that, we ask 2 basic questions. Smart mapping is all about simple. What do you want to map? Do you want to show the location only? You don't care about any of the attributes? You'll care eventually, but this is a good place to start. Just show the location, and maybe you want to style it. You just want to touch the symbol, maybe change the fill to a nice red and mess around with the outline. You can do things like that very quickly. We have another style called a heat map style. So depending on what you choose in step 1, that determines what drawing styles are recommended or possible, right? I wouldn't say recommended, but just sort of, here's what's possible given that you're just interested in the location of these points. Here's a heat map style. And with all smart mapping, you can drill into the options and start to play around with the settings. You know, there's a lot of slider bars, so you can adjust, well, you know, how dense does this have to be before I give it a heat signal? You can go like this, and now it kind of loses its meaning. You can go like that and kind of see the hot spot. You can adjust the area of influence. That has an effect as well, okay? You can adjust transparency. And lastly, set the visible range. I want it to be off at this scale, or I want it to be on at this scale. You have all those controls. You also have one more option that we wanted to mention. It's called clustering. And it's a very nice feature. With clustering, you can say, I want you to cluster up these locations so I can kind of get a sense where the intensity is, so that as I work at scale, as I zoom in, I get more and more detail. And a nice feature of Esri's clustering is that once you get to a scale where there's just one point here, well, it just shows it. And if there's multiple points, it shows them as larger and tells you how many there are. Also, you can browse the features to kind of go through. The effect this has is, in those situations where there's so many dots on a map because it's an apartment building and all the deliveries are on the same dot, or all the code violations are on the same dot, that kind of helps you out. Okay? And then another nice feature, I'm just going to skip ahead on this one, is if you choose to symbolize by, say, inspector. You know, I want to know who's doing what inspections. You just touch that attribute, and it picks the most popular inspector. It's someone with the initials JCT, and JCT is some kind of workhorse, it looks like. Notice that we sort it by top to bottom by the count, so there's more inspections by JCT than by RAM, than by TRA, etc. And notice that the clusters adjust on the fly to tell you what is the predominant inspector. So most often, in this case, there's 4 features, and most of them are by JCT. If I want to look at the individual records, I can do that.
And then can you modify the pop-up for the cluster?
The witness is being led, Your Honor. Yes, you can go in and configure that pop-up, because if you don't like that language, it's a little awkward, right? You can jump in on, oh, sorry, I went to the wrong place. You go to clustering, and you go to configure the clustering pop-up. And you can change the language, so instead of saying predominant value, you can say something like, just write a plain English sentence. Most inspections here were done by, etc. Okay? So what we find is the great maps have a strong visual, but also pay attention to the pop-up and use natural language to kind of get your point across. Good example here. In the case of mapping where things are, very simple data set called plaques and markers. It's a global data set involving what you see here. In Ireland, you can go to this location in Birr, I guess the county of Birr, and see this plaque or marker. And it's about astronomer Sir William Parsons, the 3rd Earl of Rossbart, which we all knew, of course. And in this case, it's a very simple symbol, where we're showing, we have a lot of symbols in these symbol sets that you can choose from, but oftentimes we want to do our own thing. And the way you might do that is to go get a URL to an image. I uploaded this ahead of time and pasted it in. And so that symbol is coming from a website. I know it's going to be there, and I'm able to apply it. Quick word about even mapping these simple things. This is where we all start. Usually for most organizations, it's the topographic base map. I think this looks okay, but I do want you to notice what a dramatic effect the backdrop of the map has on the symbol you choose. Right now, these symbols have kind of a dark tone or quality to them, and so they don't look as good on the light base map as they do on a dark base map. They kind of pop off the dark base map, don't they? All right, so I just want to make you aware, part of smart mapping is being aware that toning down your base map can oftentimes help your subject matter stand up, as it were, right? Because I'll only speak for guys. As guys, we tend to say, well, if a little color is good, a lot of color is going to be better. It turns out that's the opposite. When you're trying to make things clear, you want to desaturate your base map or make it a monochromatic, I said it right, background so that your subject matter can stand up. Cool. And let's go back to see where we are in our step. Oh, yeah.
Yeah, so this is an overview of the clustering that Jim showed. This is a map that shows the U.S. wildfires from 1980 to 2016.
A lot of wildfires.
A lot of wildfires. The map on the top left is showing all the points without clustering. And then the bottom right is with clustering, and we start to see patterns. It becomes a more meaningful map, showing red is the natural cause, orange is the human cause, etc. So we start to see greater patterns when we use clustering with the data set with lots of points.
Are you saying the one on the top left is wrong?
No, it's still a compelling map. It caught my eye, but it's not as meaningful.
Yeah, it's always a balance. It's an editorial position. If you want to get someone's attention in a very shocking way, the top left map certainly does it. Looks like the whole country has burned down, right? But it turns out the top left map is suffering from the fact that the symbol choice is taking over. The symbol's so large that it's just dominating the map. When you cluster, it gets a little bit more towards the reality.
So we mapped where things are, simple locations. So now we're going to take it a step further and map what things are, add a dimension to it, types, names, class, different categories. So we'll go through, or we'll just show 2 examples, screenshot. You can do smart mapping in 3D. So the line map on the left is a type map. So is it a sewage line? Is it a wastewater line? Is it groundwater? On the right, it's a zoning map. So what's the zoning? Is it business, residential, or mixed use?
I like the map on the left because they kind of desaturated the area of focus. The backdrop is still there, but for the part they really want you to see, it's pretty straightforward. The wastewater line is a certain color, and the clean water line is a blue color, which kind of resonates with how people think about water, perhaps.
So in review, as you saw with Jim, he touched one of the attributes of his layer, and the map responded. It gives you immediate feedback with what's in your data, and some interesting stories can appear even by simply mapping location.
Now we're going to map, oh, sorry.
Yeah, go ahead.
We're going to map how much. We like this phrase, the area of the dumb default is ending. Quick confession, how many of you have ever accepted the default symbology that a mapping software suggests? We've all done it. It's okay. I forgive you. We forgive you. Forgive yourself. It's okay to do as long as you continue on that journey, right? As long as you start moving past the default to understand, hey, what am I actually trying to do here? We like this slide. Sud Menon gave us this concept of, try to help people understand their attribute data as measuring one of two things. It's either measuring, think of your attribute as dimensions and measures, right? So let's talk about measures. Very common measures are things like totals or percentages, rates or averages, medians, ratios. These are the words regular people use that the software doesn't understand, right? Software just says, oh, that's a float, or oh, that's an integer, right? It's up to us to bring that to life somehow. And mapping how much usually is done from mapping a measure of things, an attribute. In this case, in the top left corner, we've got population clusters in Rio de Janeiro. Each of those dots on the map is an equivalent sized object. So the brighter contains more people, and the pinker has just kind of a regular population. If it doesn't have a dot at all, it's in the midst of the mountains or something like that. So we're using that simple count to show where people seem to be located. We also have two examples we're going to show that I think Jennifer's going to kick off right now, the first of the two.
All right, so this is a web scene, so 3D GIS, and smart mapping is available in the web scene. And this looks nice because it's got a dark gray base, so your eyes immediately pay attention to the 3D symbols. However, if we wanted to use a different layer, like this one, to show the global total population, we see in the bright orange a greater population count. So the symbol is driven by color and by size. So the darker the symbol and the taller the symbol, the higher magnitude earthquake it was. And so we're concerned with areas that have high magnitude earthquakes and are near highly populated areas, such as Indonesia here and the Philippines up here. So let's dive into smart mapping with the earthquake layer. So we've got the 3 layers here. We click on this layer, we can get to the smart mapping interface. And right now, the attribute I'm mapping is magnitude. And you can map it in 2D on a 3D scene. Right now, it's using the 3D counts and amounts. And you can also map 3D objects. So what I like about the 3D objects is that there are lots that you can choose from, and they're very detailed and beautiful 3D symbols, from vegetation to city scenes, such as the lamppost and a bench. So I'm going to go into 3D counts and amounts. And we see this slider. We've got the average, the X bar, and the average magnitude earthquake in the world is 3.7. Now that's a good starting point, but what I really care about is those meaningful magic numbers we were talking about. I was looking at a chart earlier and it said something like 3.5 was anything below 3.5, it's recorded, but you can't feel it. And anything above 6 is something that you can definitely feel and can start to cause damage.
So I love that view because the histogram tells you what the data has to say in this particular data set. the color ramp is spread across the data, and the slider bars tell you at what point am I going to get a dark blue color. And based on Jennifer's reading of the literature, at 6.1, was it?
Yes.
That's the point at which she's editorially chosen to apply that dark blue color. Another approach she might have chosen is to drag that dark blue all the way to the outlier at the top. So the only earthquake that can get that dark blue color is the biggest one. And the challenge with that is, well, that means everybody else in the data set really struggles to stand out. So editorially, it's a question. What are you trying to emphasize? Are you trying to emphasize the typical earthquakes? Sounds like Jennifer's trying to do that. And so she set her 3.5 and 6.1 based on that decision. It's an editorial choice.
Yeah, there are a lot of symbols you can choose from. You can change it into the cube. And then with the color choice, this is a light blue base map. So I'd want something like this, but I would invert the ramp so that light blue is on the bottom. The light blue kind of fades into the base map, and the dark blue stands out a little bit more. And we can also add labels with the light and the dark version of the labeling.
Does that make sense? We're trying to kind of work up from fundamentals, and then at the end, you're going to see some stuff I hope you're very, very excited about. On this example, collision warnings in New York, I think you worked on this, right? Mm-hmm. Is this collision warnings of what?
This is Mobileye data. So the buses in New York have sensors, and when they almost hit a car, they almost hit a person, a warning goes off and it's added to the data set. So we have millions of points, and we aggregated them into hex bins. So the brighter the color, the more collision warnings went off. And so those are more dangerous areas in New York.
So literally the map lights up, and it's up to an analyst to help figure out, well, why is this area so much better than this? Is it just the quantity of traffic? Oh, I wanted to show one more, didn't I? The Lewitt Trail. Mm-hmm. Okay. We have an interesting data set. Kelly Hutchins put this together. On screen, you can see an area in Oregon, and there's a trail, I hope you can see, called the Lewitt Trail. And you start at the southern extent of the map, and then you move your way up. And we were kind of interested in, I wonder what would happen if we had GPS tracks. And Kelly provided these, and I'll turn them all on so you can see there's GPS tracks all the way around the trail. So what if we were to smart map them? What if we were to say, yeah, I'm interested in the elevation at each position, and instead of using size, I want to use color. And I want to help this map out a little bit, and the way I'm going to choose to do that, you can already see a little pattern going on, but if I drill into the options, I can kind of see that the average elevation is 1,200 meters. I presume it's meters. And if I drag this up to the outlier, which is the maximum elevation gained on this trip, already I'm starting to see a little signal in the map, right? Can you see some variation? And if I touch the symbols now, I want to show you a couple little super secret tricks. Now, we don't tell everybody this, but because you got up early in the morning, let me tell you this. Even smart mapping still emphasizes too much on the outlines, right? So I always tell people, go to the outline and just for fun, turn it off. Give it a break. And I want you to see immediately those outlines, because they were a 1-point white symbol, they were actually overlapping each other so much they were destroying the color. Keep an eye out for that. Where else does that happen? Maps of census tracts for cities. When you zoom out far enough, all of a sudden the outlines start to go and collapse in on the fill pattern. And the fill pattern was the whole reason you were building the map. So anyway, mess with the outlines. I highly recommend turning them off to start, and then if you need them, bring them back. The color we can choose from a ramp. I think we chose, for our demonstration purpose, a nice bright yellow to red. Okay. And now you get a sense of where the high side is and where the low side is, that I guarantee you, if you just stared at this hillshade map, you would not know where am I going to be gaining elevation and losing elevation. And what's fun about this is when you put it all in motion, you can kind of, if you take breaks every 15 minutes, you can kind of see where we're going to need a break at different stages of this hike, right? Or different amounts of rest, or maybe a different pace. We're going downhill there, we're starting to climb there, we're kind of level there, level, climbing, okay? That's kind of fun. You're not going to find that kind of map in a textbook about cartography, are you? That's what we're very excited about with smart mapping, is just the ability to easily try something out and see if it adds any value. So let's go back to our slide deck and move on to
in review. So we can use a combination of size and color and transparency to really make your layers shine what you want people to pay attention to, and everything else just diminishes into the base map, what's not as important. And we can create maps of counts, which we showed, and a lot of times percentages, rates, ratios, indices, those make your map even more meaningful.
Yeah, traditional cartographic print theory is that, don't map counts. You need to normalize everything. As you just saw, just having the count, the elevation value, and expressing it across the map has a different map product. It created a different map experience. And you want to keep your eye out for opportunities like that. Relationships, Jennifer. It's all about relationships. So who's next? Is this me? Or you,
yeah.
This one's you.
That's me.
Okay, good.
All right, so mapping relationships in your data, these are different examples, and you see the rendering styles on the right. We can do color and size. We can do ratio, which is compare A to B. Predominant category. Look at all my fields and tell me which one has the most, and so forth. So I'm going to demo the change in forest area from 1990 to 2015. So here in green, China has gained a growth in forest area by over 500,000 square kilometers. Similarly, Brazil has lost 500,000 square kilometers in forest area. So this is the style of map that is two relationships. One is a category. Did it grow or did it lose forest area? And the second variable is the actual quantity of change. So we've got the two attributes in one map. We don't have to make two separate maps. We can put it together into one. So that's all I'll show. If you click on options, you can look at the types. So did it lose forest area or gain? And you can change the symbol. This one is using a custom symbol that I got from online and copy and pasted the URL into here. And then with the counts and amounts by size, we showed this already, so I'm going to turn it back over to you.
Yeah, another example of mapping relationships in the data, I came across this map and I thought, I think we can do a map makeover live in about 2 minutes with this map. This is the default base map. I'm immediately going to switch it to a neutral one so that my subject can kind of stand out. And the person who built this, they did a decent job. Actually, look at these aliases. By the way, if you assign aliases to your layers, to your services, to your layers, to your web maps, everybody downstream of that benefits because they don't have to go to a metadata document to look up what does field tote NPST mean. They don't have to look anything up. It's right there. It tells you its total number of private school students enrolled in ratio to total student school enrollment. That's a long alias. Probably should shorten that one. But notice that this is much more navigable and understandable because someone took the time to just tell me what this field name means. Now, they did a decent job with smart mapping. They kind of said, okay, I'm going to use an unclassified approach. I'm going to let the data kind of spread out across this color spectrum. And this is the ratio of private school students to total student enrollment. So tell me, which states have high private school enrollment? One answer is the purple states. Here's the problem. They're all purple, aren't they? What if we were to ground this map to make it what I call CEO proof? Right? What if we were to make just a couple little changes with this thing? And I want to show you this really cool feature. I've got a count of the I got a count of the number of students enrolled in private school right there. and I choose it. And the map flutters and adjusts. And then I say, no, I'm going to add a second attribute. I'm going to touch the attribute called total number of students enrolled in public schools. So I have two counts, right? And let's say for argument that covers, we don't have homeschool in here. So let's say these cover what we want to cover. These two cover the universe of what we're interested in. And there's several styles suggested, one of which is called compare A to B. Watch what happens. I just touch it, and immediately it responds and says, okay, I'm going to make this map where, if you read the legend, it says basically private schools, what's the ratio of private school enrollees to public school? Look at the legend though. Who wants to go into the room with the CEO with that legend? Sir, it's a 0.118. What does that mean? Wouldn't it be nice if there were a button you could just touch and it would say, well, obviously you're interested in the relationship between these two numbers, but we don't know what it is. We're going to let you cycle through the two options. So I just changed the label and the legend to say now, show A, private school, as a percent of the sum of A and B. I want that. Or I could hit it a third time. Let's say B was the total, some kind of total population, right? I could choose that. And you just cycle through there. It's all the same math, but it's all about the presentation, isn't it? Sir, 10.55% is the high. Now, which states have a high private school enrollment? All right, truly, the purple ones. The red ones do not. You can then go in and pick, a different color scheme if you like. The other thing I wanted to show is just a quick conversation about classification. Let's go back to what this original map showed. Where's my field? Total number in private. And you know what we'll do? We'll just hit that button and go back to our original state. The original map, quick note about classification. I mentioned, you may have noticed, that this is using an unclassified color approach. In other words, we all probably saw maps like this classified, right? Where everything at 10.9% and above, it's all colored the same, right? And that's what this map is saying is, it doesn't matter. If you're at 14% or you're at 10%, I don't care. It's the same color, right? Why would you do that versus an unclassified? Well, one useful pattern is to think about is when you have a policy, let's say the federal government came out and said, any organization or any state where membership or private school enrollment is 11% or higher, you are no longer eligible for certain federal funds. That's a case where truly it doesn't matter if you're at 11% or 12 or 13 or 14, it's all the same. The reason to kind of go this approach is to say, hey, I wonder which states are on the verge of crossing the 11% threshold, right? And that's a very different question. The big difference between traditional cartography built for the printed map is you don't get a chance to touch the printed. You can touch the printed map all you want. You're never going to get any more information out of there. With web maps, you can touch it and it'll give you the statistics, the exact value, so you can make your decisions. You've got another example.
Yeah. So the last example for mapping relationships in your data is a predominance map. So you've got your Excel sheet and all these different columns. Here in this case, we've got industry in the US, healthcare, manufacturing, agriculture by county. So the rows are counties and it has the number of people in the healthcare industry in one county, number of people in manufacturing in that same county. And we put them all together and we say, okay, in this county, which one has the most? What's the most common? Here in purple, near Detroit, we've got manufacturing. The symbol size is a different attribute. This is the number of people in that industry. Las Vegas is here in yellow. Accommodation, food services, that makes sense. And green in the middle of the nation, agriculture, forestry, fishing, and hunting. And it's smaller, only 382 people in that county, although it is the most popular or most predominant industry. We have a small symbol size. So I'll show you how to make a predominance map. So this is currently in dev, but in the next release, the 10 options will be available. But if you want to speak about that, Jim.
Oh, yeah. Predominance is a map. Predominance is a map style that looks across multiple columns of data and says, you know, these are all kind of conceptually equal, but which one has the most? Whenever you see a red state, blue state vote election map, that's a predominance map. Who got the most votes? Same thing with what Jennifer's building right now based on how many people are employed in these various industries. It looks across those 10 columns of data and says, well, who has the most? And whoever gets the most, we're going to say you, quote unquote, win. Not win, but you know what I mean. You have the most of the activity going on there. This is very useful for things like how does income vary across a city? How does education level vary across? All those census table or CDC tables where you've got multiple columns and you map percent employed in healthcare. Then you make another map, percent employed in manufacturing. And then you make 8 more maps and you are asking your user to synthesize that into a picture. That's interesting, but a more successful pattern is look for, and this is my takeaway for you, is look in your data for opportunities to find the map that's at the intersection of 2 or more attributes, not just what is explicitly expressed as a single field, but ask yourself questions, and that's a big part of what smart mapping is about. So how'd this turn out?
Yeah, it's answering the relationship between your data. So this is a typical choropleth map, not as interesting as when we incorporate the size element, how many people. And
because not all counties are equal.
Right. And the first thing I like to do is remove these county outlines, like we talked about earlier. So let's get rid of those. So now the map is breathing a little bit better. The symbol will remove the outline. And then the map becomes a little softer. We can look at the average, and you're starting to see a pattern here of how to make better maps. So now we can start to see the predominance level for each of the counties. And what's new, or what will be released soon, next month, is the new predominance ramps. So before it used to be all just unique colors, didn't really have a meaning, but now we have sequential ramps. So these are good for sequential data sets like ranges of income. Who's making over 200,000 a year versus less than 20,000 a year. We have the sequential ramp for that. Or educational attainment. In this county, what's the most common educational attainment? Is it a master's degree or is it a high school degree? So we can see the varying colors. For this one, though, we don't need a sequential ramp because they're different categories. And I'm looking at this map and I think the blue might be a little too blue, so you can change the individual colors if you want as well. And it's also, the strength of the predominance is shown by transparency. So if it's not as strongly predominant, it's going to fade into the base map. If it's most people in this county or in this industry, it's going to be a solid color. And that automatically was applied for me.
Cool. Yeah, those are exciting styles. When you're building these maps or directing people to build maps like these, or just using the Living Atlas or any content you find in ArcGIS Online to incorporate into your maps, into your apps, we wanted to show you all these examples as a way of sort of stimulating your thinking in the same way we're within Esri trying to find these new map styles, right? It won't be the case that smart mapping as implemented in ArcGIS Online will contain the universe of possible map styles, but we are putting more and more in there over time. And just by way of review, when you've got multiple columns of data, a rate and a count might be interesting, a dimension and a measure, or 2 measures, or a predominant style. Those generally are the things that work well together. Now to my favorite part. How do we map data that doesn't exist? In the old way is what? You get your data, you have to own the layer, and you have to add a field. Is it going to be a float or is it going to be an integer? And I'm going to calculate, I got to handle the divide by 0 situation. I got to write code around that and null values and gosh knows how many other things. Well, the new way is do this, try it, be successful, and share it. So some of the things we're going to show you real quick is how you can transform your data on the fly using Arcade, use logic trees and thoughts, about how I'm going to organize this, handle exceptions, and classify the results, and in fact invent new map styles. So I've got one example kind of right away. We already built this into Smart Mapping where, let's go back to our complaints data set, and I'm going to touch this complaint date field. And in this case, ArcGIS Online says, oh, it's a date field. I have map styles for that, and we list them for you. You can map it by color, which is on screen. So you can map it by size, where more recent complaints are bigger, because it's almost like bubbles that come up on the map, and then as they get resolved, maybe they go away or they become transparent, you know. Maybe I'll do something by age. One of my favorite map styles is the by age using size, right? And what I mean by that is it says, hey, I'm going to set this map style up based on the delta from the complaint date to this date, meaning today. And big things are going to be recent, and old things are going to be not so recent. And in this case, I'll do, let's not do hours. Let's go to, let's say, months. And if you're a really old complaint, you're big right now. That's not what I want. I want the young ones to be big, and I want them to only be big if they're like 3 months old. What do we got? We got 22 as a minimum. So as we drag this down, we take control of the map to say, these are what's important, these are what are not important. And when you kind of work it all the way through, you can end up with a map like this, where you're using size and color to show some measure of intensity. And if I show the legend, you'll see what I'm talking about, okay? So the more recent ones are in red, and the age in days from complaint date to compliance date is the basis for the size. So recency is one aspect of this story, and the other is how long has this been out there on the books?
So what does the field look like? I mean, let's see the table.
Oh yeah, it's just a date field. There's compliance, for example, and the complaint date was over here.
So all you need is a date field, and then Smart Mapping will calculate how old something is, or how new something is. Or...
Yeah, this whole project came about because we realized date fields are special. There's probably other fields out there that are special as well, or combinations of fields that you might think about.
Okay. I'll show you one example of arcade expressions.
Yeah.
So this is a map that shows pre-kindergarten sites in Albuquerque, and the red symbols represent sites that are over capacity. So there are 110 kids here. The site can only hold 94, so there's 16 kids over capacity. The green symbols, notice how the pop-up color is changing and the text is changing depending on what symbol I click. So these are at capacity, 20 kids enrolled, and it can hold 20 kids. And then the blue symbols are sites that are under capacity. So we use arcade expressions to map these two variables. What status is it in terms of capacity? And then size, how much over or under capacity is it? And to do this, you go to the step one, scroll to the very bottom, and it says add a new expression, and this interface pops up. And here you can write your code. It's like Excel in a sense. You can do if-else statements. I like, instead of using if-else, I like using when. So when difference is less than 0, return the category capacity. So what it's doing is looking at the numbers and then assigning a category. When difference is equal to 0, then this is at capacity. And then for all else, we'll say at the end, below capacity. You could also do null to say return nothing. You can even test it to see what it is. And these are all your fields in your data set. So what it's looking at is the slots and enrollments field. And this is like a little playground. You can change the number of slots available in the site to 10 and see how it says below capacity. We can test it again, and now it's running through your code and seeing what the output would be given those test numbers.
What do the functions look like?
Functions are fun. So there's absolute value, there's average, we have even geometry. Is it within something? Is it intersecting something? There's just lots of functions you can choose from, and there's info that explains what the function is. There's also constants, and existing shows your other expressions that you've written. So the second arcade expression uses one of those functions, the absolute value. So let's calculate the difference and return the absolute value. So if it's under or over, by how much? Because if it's under, it's going to be a negative number, and that wouldn't really make sense. This is under capacity by negative 10 kids.
Oh, you need absolute value so you can show the size of the symbol?
Right.
Oh, okay.
Yeah. And you can use arcade expressions for your symbology, your transparency, rotations. If I wanted to turn these kids over, could do a 90-degree, you'd use arcade expressions for labeling. I'm going to show you how we used arcade expressions for your pop-ups. So all of this is not in my data set. So say you don't own the data set, you can't add a field. You can use arcade expressions on things that aren't your own. That's what's so great about arcade expressions. So I have 3 different pop-ups that show 3 different colors and 3 different texts. The one for overcapacity, the one in red, says, okay, when the difference is less than 0, give me the absolute value of the difference, so 10 kids, and then return this text right after, kids over capacity. If that doesn't meet the requirement, return nothing. And so that's a similar case for all 3. And when you configure your pop-up, you put the 3 expressions. So it's going to meet only one of the 3. If it meets the first one, it returns that number in the text in red. This one's a different text. There's no number, it just says at capacity. And what's great about the pop-ups is you can also embed your own code here as well.
That's just HTML?
It's just HTML,
Nice.
Yeah. And the way you add your expressions is the way you add any of your fields in your data. At the very bottom are the expressions that you created, and you just click on it, and it adds it, and then you can modify it from here. So that's all for that.
Yeah, I've got another example. This actually happened to me live. About a year ago, there was a demonstration, and someone I know came up and said, I'd like to see this map. And he described it verbally to me and said, can you do it? And I said, well, I'll need parcels data. Unfortunately, there's open data out there. And can anyone spot my biggest, they wanted to show something about the property value and the improvement value, the land value, the property value, and the improvement value. Can anybody spot the first problem I have with making a map based on land value? It's a text field. So am I going to call the county and tell them they made a mistake and publish their data with a, no, I'm not. I'm going to go into my arcade. I'm going to take that land value. I'm going to replace the any comma I find in there with an empty string, and I'm going to convert it to a number. I'm going to then write logic that says, hey, when land value is 0 and improvement value is 0, they're both worthless. Not worthless, but they're in the database as 0. I want you to represent them as equally valuable, 50. 50, the land value as a percent of the total is 50%. Oh, and when land is not equal to 0, but the improvement value is 0, then land is 100% of the value of that property. Otherwise, just do standard math and apply it. And as a result, I've got the ability to tell this kind of C-level person, hey, I made you your map, and we were able to incorporate it into a story map about properties near the proposed Redlands passenger train, so that we can see, well, where are the developable properties near each stop along the way, right? So there's a lot along this property, and you can touch it. Just like Jennifer, I used some color to inform the map a little bit further. And in the same way, you as developers, I think there's a way to listen to people. We had people from the National Governors Association talking to us about this massive spreadsheet tracking 20 years of commodity exports for every state, dairy, broilers, poultry, plant products. They said, can you make maps out of this? Like, sure, what do you want to know? Well, we really want to know what's changing. Like, okay, so we kind of did the standard thing where we're showing things like growth in exports over time, and year-over-year change. This particular year's everything in red decreased, and the size tells you by how much. But they said something interesting that really caught my ear. They said, we really want to know from the spreadsheet, what are the up-and-comers? What do we need to pay attention to? We know what our big industries are. We want to see what the fastest movers are. And so the thought was, yeah, if I could kind of start to explore, well, what was your predominant export by state? And maybe I could then analyze not the predominant, but what moved the most. Year over year, who changed the most in either total dollars or percent? I chose total dollars, and just a simple, well, not simple, but it's a straightforward arcade expression that looks kind of like this. I called it the predominant gainers, and the expression turns out to be something like this, where we go get all the fields out of that layer, and we treat it as a predominance. But instead of picking the biggest one, what I'm picking is, hey, take pork 2015 and subtract 2014. I'm interested in who moved the most. And this is the kind of thing I think gets me excited as sort of a map person. I hang out with developers enough to be dangerous or to find a good one when I need them. This is what gets me excited, is maps that in the old days, what we would have done is, again, we would make a map of fruit and change in fruit, change in pork, and we'd make an atlas, wouldn't we? We'd make an atlas. We'd build an atlas and hand it to them and say, I hope you find this useful. Sometimes I think it's very exciting these days to kind of look at the map as a way to get to exactly the information they're asking for. In this case, what changed the most year over year. So we have a little time for questions, and we'd love to entertain them as we kind of wrap up here. I don't think we have any. Yeah, we should kind of talk through all those. We talked data transformation, string manipulations, logic, and common sense. Yes, you can put common sense into your code. We've got some resources. I'll leave those on screen in case you want to jot those down. I think we're happy to take a few questions in the time remaining. Sir?
So you indicated that not all these features are currently available. Where is the breakpoint?
Everything we showed you here is available today except for the 10 predominance. Right now, predominance on production is limited to 5 classes. It's going to 10. That'll be coming out.
But until then, you can use Arcade to do more than 5.
Yeah. Yep.
When you show the agent example, we tried to use that before, but I'm not sure how to explain it. The date would stay fixed. So you had to enter the day's date as being the date at which you start. Will that slide forward now? So tomorrow, you'll still do the update?
Yeah, that's a good question. The question is, on the date style, is there a way to get the date to continuously slide forward? In that implementation today, no. In the future, we're still looking to get that to be the concept of today. In code, you of course can do anything you like to keep that fresh. Yeah.
So arcade is the way to go then?
Arcade is the way to go then. Yeah, there is a now concept in Arcade. Yeah.
Is the format module only for online? The Pro has the development module now?
I'm sorry.
Does Pro have smart mapping? So the question was, smart mapping is found in online, but it is also found in Pro. And there's a smart mapping API that you can implement in your code too.
Yeah, I really like Arcade in that the things you do in Arcade work in Pro as well. They just come in. If you have a layer or a web map, you open in Pro, the Arcade expression is there exactly as you wrote it. So we've used that successfully, for example, with city planners. People who have a vision for how are we going to rate these parcels and their value to a community. You know, sometimes they have a secret sauce about how they would evaluate site selection, and it's a nice way to give them a formula, let them work with it, and when they're finally done, they can share a version they're willing to share back as an Arcade expression with whatever weights they want to apply. That's kind of a nice experience. Any more questions? Yeah?
Maybe several more. So on the clustering, I just learned that version 4 of the API doesn't support the clustering on the web map. So what's the suggestion on having a web map that had lots of points that needs clustering?
The suggestion about clustering, yeah, it's on the 3x. You're telling me new information to me that it's not in 4x yet. Yeah. So I would emphasize the word yet, most likely. Clustering is a very popular feature. I don't see it, personally, I don't see it going anyway. That's not an official statement, but I can't imagine. And so I would say go ahead and build the web map on the 3X platform, you know, the current ArcGIS Online, and know that that web map will work in well, it depends on your application, I suppose. When do you want to migrate? Obviously, you don't want to migrate to a 4X platform if it doesn't support the map style you want.
Yeah, too late.
Okay, so you're already
So
got.
it's more of a cartographic question. How we have heaps of points that are really tight to each other. They don't, you know, when you zoom into the parcel level, then they
Yeah.
separate out.
You know, a real valid approach, I always recommend, I love heat maps. They're beautiful. They're meaningless. They just make you feel good. And sometimes we need to feel good about our data. A more scientific approach, I guess, or reasonable spatial analytic approach is to take hex bins like Jennifer's got on screen and summarize your dots into those hex bins and then deal with that layer as just a standard polygonal layer. That is a more, I think, responsible way to represent what's actually going on.
So this is millions of points, and we use the analysis tool in ArcGIS Online or Pro to aggregate your points into polygons, squares, or hex bins.
So this gives you the opportunity to say, in this case, how many accidents? Okay, so now we know how many accidents fell inside that bin. What we need to know is how much traffic goes by or through that bin every day. And that helps us normalize and kind of understand. That would be the next step for this map. Sir?
So organization has limited the number of features that can be displayed on one map in total at a time of 2,000. If you have a lot more data points than that, can you use clustering or binning to overcome that limitation?
Yeah, the 2,000 limit is rapidly disappearing.
We're working with MGA, they said they would.
Oh, all right.
Unfortunately.
Okay, yeah, if you just have to deal with it, if it's me, I'm going to deal with it behind the scenes, binning things up 2,000 records at a time till I exhaust my record set. Now I've got the definitive binned version of that data, and I can work with that.
So this one has over 6,000 points, and it's working without clustering and with clustering. So I've seen a big change over the past few years of how rapid the points draw. So 2,000 is kind of an older number now for what I've noticed.
Yeah, well, I think what you're saying is there used to be sort of a technical reason why it was limited just for pragmatic reasons, but that has gone away. So now if it's a policy decision of a customer to force you to deal with 2,000 at a time,
Right.
On the client side, that's obviously going to be limiting, you know, I can only zoom in this far, and you still may not know if you got 2,000 features or not. But that's one way we mitigate things is, all right, well, we can only work at this scale. You know, it's kind of like drawing all the census tracts for the whole United States. There's no point other than to say you could do it, but you can't see any detail in the cities. You kind of need to summarize what's going on in that Los Angeles area because there's like 4,000 pieces of data in that one area. I don't know exactly how it applies. So if you want to hang out a little bit afterwards, we can chat. And that goes for anybody. If we're at time, so if anybody wants to depart, thank you for coming.
Yes,
if you want to
thank
hang
you.
out and ask more questions, we will stay put. Thanks for coming this morning and getting up early.